Hi, welcome back to Hail Design Technologies. My name is Jeremiah. Thanks for joining me. On Hail Design Tech, I am trying to make a micro manufacturing fabrication shop in my garage, building all my own hardware. So I'm knee deep in a project I'm lovingly calling the Autocrafter, which is a multi-process machine, 3D printer, plasma cutter, probably CNC router as well. Haven't got that plan finalized yet. But I'm hopefully going to be adding on to this machine, and it's going to become my workhorse. So what I've done in the last episode is I've increased the Z-axis lift on my Autocrafter, basically doubling it. It was 250 millimeters, now it's 500. I think I could do something with 500. Now I've worked myself into another engineering corner, I guess, because I have to rebuild my hot end assembly. So the hot end, if you don't know 3D printing, is where the plastic comes out and it's heated. That's why we call it a hot end. So that's the business end of a 3D printer. So I gotta figure out how to remount that, as well as the extruder that pushes the plastic filament, we call it, into the hot end. And then throw in a BLTouch in there for added measure and complexity. So that's what hopefully I'm gonna get done in this episode. So wish me luck. Let's get at it. Okay, now I've got everything taken apart, and now I need to figure out an elegant way to mount this hot end assembly and this, come over here, you're way over there, and this extruder to this plate. And what I want, the ultimate goal, is to be the actual print head to be as close to this plate as possible. The closer it is, the more Z-axis travel I have. So the farther it sticks down there, it just cuts into my Z-axis up and down total distance. And I want it all. So I'm gonna try to engineer a way to mount the extruder and hot end on this plate as easily as possible. Okay, so my idea is to use one of these 80-20 C-beam extrusions. C-beam is what OpenBuild calls them because it's shaped like a C. And I want to use it to mount my extruder. And I want to put the extruder motor in this slot. So I'm going to end up having to cut this to be as short as possible to mount this out here because I got that big old motor sticking out there. But now I have another problem. What I want to do is try to get it in this slot here, but the motor, move over here, but the motor's a wee bit fat for that. I tried already, maybe taking a little off the edge. I don't want to take too much off the motor. So I'm gonna have to relieve this inner channel a little bit to make the motor fit in there. And so that's gonna be my project next, is to cut this down to size, relieve it, and then make a nice little mounter for my extruder. Then once the extruder fits in here, I'm gonna mount the hot end off the end over here. So that's the plan, let's get at it. Okay, well, bump the camera. Okay, I was able to get this cut. I just used a hacksaw, actually. Worked pretty well. Then I used this little square to sort of guide my hacksaw blade. Wasn't the best cut in the world, but worked out well. And a nice flat cut. And I was able to grind it in a little bit with sandpaper over here and the angle grinder. So took a bit of angle grinder, ground down these edges a little bit, and then finished off with 200 grit. And it's tight. It's really tight. But if you give it some English, she goes in there. Perfect. I love these plates, man. These OpenBuild's Extreme mounting plates. Basically, they're already pre-drilled in places that fit really nicely with 80-20 extrusion. I'll probably take these out and Loctite them as well. All right, so that's on there. 4 holes, 1, 2, 3, 4. Leaves myself a little bit of room below the plate here to mount my extruder and hot end. That'll do. Now let's fit the extruder on here. It's a planetary gear reduction and a regular NEMA 17 stepper motor. And this is called a Flexwheel. Well, if you couldn't read. Flexwheel Extruder. These guys are out of Sydney, Australia. I think they're Sydney. I've had this bad boy for probably the last 6 months or so, and I'm still getting used to it, but I think I've got all the bugs worked out, and I'll probably do a review on this extruder once I get some more prints under my belt. Hello, how are you? So I've decided to affix this extruder to this end piece, but I'm going to take it all apart and then drill and then countersink a couple holes into this back plate here, and then put screws in from this side, only in that bottom plate, then assemble everything back on there. I think that's going to be the cleanest, neatest way to go, and really the main reason for that is I don't want two big old screws sticking out of the front end of this beautiful looking extruder. Okay, let's get this thing apart. Never taken this thing completely apart like this before, other than to replace one of these plastic pieces. So when I originally got this extruder, it came with some really good emails back and forth between the manufacturer and myself. I just ordered it off their website. They had no idea who I was, and they still reached out and said, hey, how do you like the Flexwheel Extruder? And so I gave them my initial feedback, what I thought about it, and they sent out on their own dime later on replacement 3D printed parts here, because part of this extruder is 3D printed, and apparently there was a flaw, or a minor flaw, in the original design. So I think they ended up moving this hole over like probably a couple thou, I don't know, and they sent out a whole new printed piece. They didn't send me the STL file and say, hey, print it. They sent me the actual printed piece, which was pretty cool. Now this is the next time we get to take it apart, and I'll take it apart on camera for you guys so you can see what's in here. And I'll show you why it's called a flex wheel. Pull off this front plate after you take off those 4 countersunk screws. You get to the 3D printed bits, and there's relief holes machined into this side for these proud screws here, which was pretty cool. So let's get these apart. Got those off. It should pull right off this way. And so this piece and this piece is something they sent me as a replacement. So I've actually took this apart and replaced this already. But I want it off completely so I can get to this back plate here. And so I guess the reason they call this a flex wheel is this wheel here, it actually grips the filament, and then it's squished together by all these bearings with the clamping jaw, which has bearings in it as well, and actually look like teeth. It's kind of funny. And why this design? I'm thinking if you've ever really used extruders in the 3D world, they all use this cog pin style extrusion. So basically it's 2 points as a pinch point. One side is a bearing, the other side is this cog gripping wheel that grips on and pushes against the bearing and pulls the filament through and into your hot end and then onto the print itself. So that's the normal style. And the problem with that is if there's too much pressure here, the wheel will dig into the filament and literally cut a hole in it, and then will just spin. If there's too little pressure, it just spins. If the wheel gets clogged with dust or whatever, then it'll also start to lose grip and start to spin. So these are all the problems with the normal extruder, and this flex wheel solves all of those problems. So instead of grabbing the filament in one point and pulling it along, this has 180 degrees of grip all the way around it. So think about pinching the filament and pulling it around and then dropping it off. I did a test with my own strength to stop this thing from extruding, and I literally could not stop the extruder from extruding filament, pushing, basically forcing it back in there as it was printing, or actually as it was rotating. But anyway, where was I? Now I just got to drill a couple holes here and here, I'm thinking, in the meatiest part of this plate. That way I can just screw right into this base plate here, relieve these holes so a millimeter or so flathead, ultra thin flathead, will just sit right in there. So that's the idea. I just need to figure out exactly where I need to drill, then go ahead and punch through right here and there. I'm going to push the plate back until I can see where the hole is. Then keep my Sharpie directly above that hole, squeeze, and drop. And then to minimize spot error, I'll just make the hole a wee bit bigger than it needs to be. Same thing on the other side. So there and there. So let me get those drilled. I love step drills. So the bottom of this plate here lines up with the trough, bottom of the trough of the groove. That way everything matches and looks nice and neat. All right, cut some relief out of this with a big old 1/2-inch drill. I figured that'd be the best way to relieve as much lower meat as possible on the bone. And it looks like it's gonna work pretty well. Those holes are way bigger than I planned, but should do the job. Just freshly tapped holes, run these screws down nice and smooth like. Excellent. I swear, like, being able to drill and tap holes is like having a superpower. It makes you pretty versatile in a shop. Because you can just put stuff wherever the bleep you want. Like, oh, there's no hole there? Hold on a second. I've got a superpower for that. Pretty flush in there. This one's even lower. This one's very, very slightly proud, just minimally, couple thou. All right, I like that. Just hit it with an angle grinder for a hot second. Now it's a lot more smoother. Basically a flat shelf now. So let's put it back together. That's one piece now. You're on there, babe. You're on there. Okay, this is getting messy even for me. So let's clean up. There we go. That's a bit better. All right, now I gotta mount this hot end, or the business end of the 3D printer. This gets pretty warm right here, to this 3D printed plastic part. So I'm gonna keep these things separated as much as possible. So I want it like this, probably. So the farther out on this as possible. Then I'm trying to figure out a way to mount it to I'm probably gonna mount it directly to this extrusion with a angle block and you may recognize this, spacer plate. Man, that got dirty. So I'm thinking something like this. These have already drilled holes because this is the last one. Reusing this, I guess. But I could just make one of these from scratch, from aluminum or whatever. This happens to be stainless steel. And then slide this on here like so, and mount everything up. So the only new attachment thing I have to make now is just literally drill and tap a hole in here. Going to, since this is stainless steel, I'm gonna sneak up on the diameter that I want with a number 42 drill bit. Why 42? Because it's 42, the number for everything. So 42, start it up, 17 to finish it up, and then we'll tap it. This piece is pretty small, so all it wants to do is spin on this thing. Throw another C-clamp on here. Hopefully stop it from going anywhere. At least it gives me a good handle to hold on to. But yeah, it literally wants to snap. So take it slow. Nice and slow. Okay, cleaned her up with an angle grinder. And oh, I need to clean those threads out. Looks pretty good. Okay, to make sure this thing fits on here and aligns properly, I'm going to use a piece of filament. Load the filament in there, then run it down. Excellent. Okay, so I've been struggling with how to mount the BLTouch on there, and I think I came up with something. This may not be my final solution, but it'll work for now. And I'm keeping my theme of reusing parts from my last design. So this little U-shaped piece of, again, stainless steel is pretty easy to make. It's just a big U and cut out in the middle. And now I think I can use another block, put it in this slot here, and then hook into it like that. So the slot's pretty wide, and it was designed for like a larger bolt. I don't know why, just what I had in the hand at the time. But I think a standard T-nut spans it with about 1 millimeter on each side. So that's going to be my solution. Actually, hold on. Just designing on the fly here. Hey, come back here. Let me just hanker this down so it's not running away on me. Yeah, I said hanker. It's like anchor, but angry. Washer stacked under a T-nut. So the washer will be the one that spans the gap here. Because the T-nut would do it, but I don't trust it. It might vibrate free. So a washer will be nice and solid like that. So that's what I'm going to use to mount my BLTouch. Get it on there. Okay. Something like that. Oh, it's upside down. Hold on. Good thing you can do that. Okay. So something like that should be golden. Just go down as far as possible. And the rule is the end of your BLTouch probe at retraction, fully retracted, should be no more than 3 millimeters away from the end of your probe, from the end of your Hotend thing over here. I think it's around my 3 millimeter mark. And I can adjust it up and down a little bit if I need to. And that should do for me. Okay, my next problem is figuring out how to mount the filament roll like I had before. I'm a fan of getting the filament as close to the extruder as possible, so I think I'm going to mount it on here wherever I have room left. I still have my old welded up filament holder, piece of sheet metal with a tube welded to it. Nothing fancy dancy there. So I'm going to see if I can repurpose this and figure out how to mount this on there. Ooh, that red's really nice. Ooh. I have the other side to this beam here when I cut in half. So I think if I sneak this and mount it something like that, I'll have plenty of room up here to tack on this filament holder up here. So that should give me plenty of room. I think this might work. So let's try to attach it and figure out a good way to attach it without messing up my wires and stuff here. Okay, I think I got it. And dun 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 dun, more blocks to the rescue. So there's a tapped hole right here, and I think I can barely squeeze, if I can cope that wire down through the slot of this C-beam, I can barely squeeze a T-nut in there while sitting this on top of the motor up here. So that should work. So screw here, T-nut in there, and so this will be held on by one on this side and one on the other side. Nice and light, should be rigid enough to hold filament anyway. I mean, I wouldn't try to attach like other tools to this, but if I'm just holding filament, this will work just fine. All right, there it is. Both of them are on there, on either side. We're good. Next, hold it. It's pretty darn solid. It looks like a satellite, but it's on there. So now, I need to mount this on here, like it was before. So, something like that. Let me grab a roll of filament and see what this looks like. Oh man, the filament roll is going to hit the extruder before it catches. Oh, it goes into the slot here, so the extruder's eating it. Nom, 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 nom. Oh, focus, Jeremiah. Okay, so that's not going to work. So I have to adjust this thing. What can I do? Maybe if I turn it sideways? Sideways might work. All right, let's see if that gives me the clearance that I need. Should be still plenty strong enough that way. I may come in here and add more weld on this side. Oh yeah, all right. Sorry, Mr. Hungry Extruder. You can't eat my filament roll. Oh, wow, I feel like I'm playing with like G.I. Joes. Let's knock this out with some T-nuts and some 8mm screws. Oh man, I got a problem. this one is all, this one's all sorts of stripped out. Go grab another 8mm. Houston, we got a problem. I am out, completely out of 8mm screws. This is my last one. So, I need to order some more, but I don't want to stop my project just because I ran out of an 8mm screw. So, fun little tip. You can turn any 10mm or however long screw into an 8mm screw with an ankle biter. An angle grinder. So just grind it down a bit. And I'll be right back. Hold on. Okay, I'll show you grinding it down. Alright, there you go. 10mm turned into probably more like a 7mm than an 8, but sue me, I'm overzealous with an angle grinder. Ooh, that's hot. Hot, hot. And just to show you that it works, man, my hands are dirty. Come on. I'm doing this by looking through the camera, so. But, there you go. Screws right in. Alright, let's get this mounted. Not now, but in a future date, I'll definitely be pulling this off. Oops. And finishing this weld out. There was no problem because I had it mounted the other way. Before, this just having weld on one side. And probably having it welded all the way around is overkill. This tack is probably more than enough to hold up filament, but I'm OCD. It doesn't want to mount completely flush with the top surface here, which will be fine. It'll be hidden by the filament roll anyway. So, it is what it is. I can't do nothing about it. Get off my back, yo. Okay, here it is. In all of its finished glory. Pretty cool, right? Hold it by the filament holder. It's solid. These are solid. Everything else is solid. This needs probably some updates, but so does this. Well, maybe I'll print some parts for these. What do you say? 3D printed parts for a 3D printer? Sure, let's do that. And looks pretty cool. Leaves me plenty of extra spaces to mount other things if I want to. But I like it. Nice little small, neat package. This whole thing probably weighs about, I want to say, it's kind of heavy. It weighs probably about 5 pounds. Maybe less. Let's get her mounted. So up here. That's the problem. Hold on. Got it mounted on there with a 3mm by 15mm screw with a nut and a washer. Okay, it's showtime, peeps. Pull the camera off here. And here she mounts up. All right, look at that beaut. Brought in 6 3 down there. Got this nice and tilt up a little bit. There we go. Look at that, isn't that awesome? Oh, it's on the filament roll. Like so. Pretty cool. Now this whole beam goes up and down, and this little guy just back and forth doing his thing. That looks sweet. Alright, if you like this content, go ahead and hit subscribe. This is what I'm all about right here. Thanks for watching.